Bismillahirrahmanirrahim. Assalamu alaikum to all of you. This is Abdul Ghaffar Abbasi here. Today we will discuss very important topic of the chapter number 2, that is gas laws, which is included in our reduced syllabus. So first of all we will discuss the introduction related to the gas laws. The mass, volume, temperature and pressure of a gas bear a simple mathematical relationship to each other. Moreover, other variables such as rate of diffusion of the different gases are related mathematically. The precise statements of these relationships are known as the gas laws. In the gas laws we will discuss what is the relationship of the mass, volume, temperature when we increase or decrease, and what is the relationship of the rate of diffusion in the gases. So these relationships related to these points will be discussed under the heading of the gas laws. So today we will discuss the gas law number 1, that is the Boyle's law. So introduction, as initially I have told you that we have to write the answer in headings and subheadings. Like I have given the heading, that is introduction. This law was introduced by the Robert Boyle in 1660. In introduction you have to write these two main ideas: one, the name of the scientist, and second one, the year. Then the statement of definition or statement of the law: the volume of the given mass of the gas is directly proportional to the to pressure if the temperature remains constant. At the constant temperature, the product of the pressure and the volume of gas remains constant. So in this law, its statement is that the volume of given mass of gas is inversely proportional to pressure. Means if you increase the pressure, the volume of the gas will be decreased. If you decrease the pressure, volume of gas will be increased. So let's look at to discuss this phenomena in detail. Now the example, what is the example? Robert Boyle, he took a J-shaped tube and its shorter arm was closed. He introduced mercury in the longer arm so as to enclose some amount of air in the shorter arm. The equal level of mercury in two arms indicated that the confined air was subjected to the atmospheric pressure. The Boyles added more mercury, as a result of which the mercury level raised above the original level, and the increased pressure reduced the volume of the air. When he increased the further added the amount of mercury in the J-shaped tube, what happened? The volume of gas was decreased. So look at the pressure total was equal to the pressure atmospheric and plus pH, means the excess pressure. This was the total pressure, formula related to total pressure. Now look at the diagram to clear the concept further. Now this was initially he introduced the mercury in the J-shaped tube, and the original initial volume of gas was here, it was 60 ml. But when he introduced another amount of mercury in it, then what happened? The level of mercury raised, it increased. And now what about the volume of the gas which was inside that decreased? So this is the relation, that pressure, when we apply the pressure, what will happen? The volume of gas will be decreased. So mercury, when we added the another mercury, then what happened? The volume of gas was decreased. Initially it was 60, look at here, but now it is 30. So this was the relationship of the pressure and volume of the gas discussed by the Boyle's law, and this was the example. Now we are moving towards the mathematical derivation. Now the mathematical derivation of the Boyle's law is that volume of gas is inversely proportional to pressure at temperature. Temperature remains constant. So we can rearrange this equation as, when we will remove the proportionality constant, we will place a constant k, and then that will be 1 upon p. So we can rearrange this one as PV is equal to k. P is dividing here, it will multiply with V, so PV will be equal to k, and k is the constant. Now look at this statement related to this one. The product of the pressure and volume of a gas at constant temperature is always constant. This is the main idea. Now we are discussing in this mathematical derivation in detail. At initial pressure P1 and initial volume V1, so we can say that P1 is equal to V1 and then K will be the constant. This will be the equation number 1. At changed pressure P2 and change volume V2, we can say that now it will be P2 and V2 and then constant will be there. So by comparing the equation number 1, by combining the equation number 1 and 2, we will get P1 V1 is equal to P2 V2. This is the mathematical expression of the Boyle's law, and it is used for the calculation of the different problems related to this law. Now today we will solve one example, one problem related to this law. But before that, we are discussing the graphs, graphically representation of the Boyle's law. Graph between pressure and volume at constant temperature is a smooth curve, and that this curve is known as the parabola, and this is the very important question which will appear in your entry test point of view. Now the second graph between inversely proportional pressure and volume at constant temperature will be the straight line. This will be the straight line. Then this will be the graph between we can say that inversely proportional to the pressure and volume. Volume is inversely proportional to the volume. Volume of a gas is inversely proportional to the pressure. Now the problem which we are solving: what volume does the 400 cm cube sample of gas at 700 torr occupy when the pressure is changed to 2 atm? Now we have to how we have to solve. First of all, we have to make data. So initial pressure is the 700, so we have to convert it into atmospheric pressure. This is into torr, so the number will be divided by the 760. It is constant. This is very important point. So when you will divide it, you will get the answer that will be 0.92 atm. And change pressure P2, that is given in the question, that is 2, and initial volume V1, that is also given, that is 400, and we have to calculate the changed volume V2 according to Boyle's law, the equation which we have discussed right now, that is P1 V1 is equal to P2 V2. So if we require V2, the equation will be changed in this way. V2 will be equal to P1 V1 and P2. Now the value for P1 is 0.92, and for the V1 that is 400, for the P2 that is 2. When you calculate, when you solve, you will get the answer 184 cm cube is the changed volume in this problem. So today we have discussed the one gas law, that was the Boyle's law. We have discussed the introduction, statement, example, mathematical derivation and other graphs, and then at the end we have solved one problem related to this law. I hope you understood this law, and for the upcoming upcoming classes, upcoming videos, we will discuss the another gas laws in detail. Thank you. Allah Hafiz.